So I could find midpoints using slope patterns, and I can also think about averages of x's and y's. So, um, and also if I'm given a point and something that's the midpoint, I could extend that out and find out where the other midpoint would have to be. So that's two types of things that could happen. Let's just say that we've got points that are located. Oh, I don't need all of that. Let's locate it right here at 1, 7, and I'll put another point right here at 9, 3. And the question that I want is, what is the midpoint between those? Somewhere in here, there's a point that's exactly in the middle between them. If I look at my rise run pattern here, I'm going down several units, going down 1, 2, 3, 4 units, and then I'm going to the right several units, and it's actually 1, 2, 3, 4, 5, 6, 7, 8 units. And I could do the subtraction to get that also. But so that was down 4 over 8. Well, if I cut each of those in half, right, down 4 over 8, and make it down 2 over 4, that's going to give me the midpoint. So basically, I can travel half of the way down, land on this line, and then instead of going all the way to the 8 units over, I just go over 4 units over. 1, 2, 3, 4, and that lands right here. So this is the midpoint between these two. Also, it's kind of helpful if you look at the coordinates. If I look at 7 comma, oops, x is 1, y is 7, and I look over here, x is 9, y is 3, and then this is a different point, right? We said that this midpoint was at 5 comma 4. If I take the 9 from the x value and the 1 from the other x value, add them together, I get 10. Half of 10 is 5, which ends up being the same as the x coordinate for the midpoint. And also if I take the 3 and I add to that 7, 7 plus 3, I've done something wrong. So 7 plus 3 is 10, and half of that is 5. Oh, the midpoint is at 5, 5, isn't it? Yeah, I just wrote the wrong thing down. The midpoint is at 5 and 5. So I went down to over 1, 2, 3, 4, and I just didn't look at this correctly. This literally is the point 5 comma 5. I went down to over 4 and I landed at 5, 5 and didn't write it down correctly. Well, it's kind of nice that I looked at it two different ways because I was able to catch my mistake. Clearly, I had drawn the wrong right spot, but if I draw the right spot and then don't bother to write down the correct coordinates, that's kind of problematic for me. The other kind of problem that we could look at is, let's say that we've got a point here at I'll say it's at 8, 4, 8, 4. So this is the point 8, 4. I need to turn off shape recognition. So 8, 4, 8 comma 4, and I'm going to say that I've got a midpoint that's located at 2, 2. Oh, and by the way, this was negative 8, negative 2 comma 2. And my question is, if negative 2, 2 is the midpoint, what's the location of the other endpoint? Where would I have to be at? A nice way to do that is graphically. I can grab this pen and say, look, I'm going to go down 1, 2 units, and then go over 1, 2, 3, 4, 5, 6. I could do the same thing again, go down to 1, 2, and then over 1, 2, 3, 4, 5, 6. It looks like the point should be x is 4, y is 0. And I did that by just duplicating that slope pattern, right? Kind of doing it twice. If I were to add those, I could verify this. So if I take negative 8 plus 4, right? Again, I'll highlight these in this color. Negative 8 plus 4. When I do that, I get negative 4, and half of that is indeed negative 2. So I can see the average there did help me verify that this really is the other endpoint. And if I add 4 plus 0, I'll do this in green. If I add this 4 plus this 0, It gives me 4, and then half of that 4 does give me 2. So I can see, yeah, that truly is the midpoint, and I can find it just by duplicating that slope pattern again of down to over, what was it, down to over 6 units? One, two, three, four, five. Yeah, down to over 6 units, down to over 6 units again. And then I could check it by just averaging those endpoints and verifying it really was the midpoint.